So we're going to compare using perfect cubes and rewriting with multiplication, compare that with a factor tree. And of course, you get to pick whatever method you're more comfortable with. It's the same problem written twice. Let me start by using perfect cube values. So here's a perfect cube list. Now, if you don't know this list, all you got to do is get your calculator and go 2 to the third power, and that'll give you 8. 3 to the third power will give you 27. 4 to the third gives you 64 on a calculator. That way you know perfect cube numbers. Now, why do I write these perfect cube numbers? Because I want a perfect cube number inside a cube root. Because when I take the cube root of a perfect cube number, it's a nice, beautiful answer. Like, what's a cube root of 8? Tell me, guys, what's a cube root of 8? 2. Yeah, exactly, 2. What's a cube root of 64? 4. The square root of 64 is 8, but the cube root of 64, remember we're doing perfect cube numbers, and we're doing cube roots on these examples. What's a cube root of 125? 5. If I ask you, why is the cube root of 125 5? Just 3 times. Yeah, 5 times 5 times 5 is 125, right? So we know perfect cube numbers, and if you don't know this list, like I said, you could do it on a calculator. 2 cubed is 8, 3 cubed is 27, and so on and so on. Now, we want one of these numbers in here, but we have a 256 in here. Now, 256 is not up here. So I need to rewrite with multiplication to get one of these perfect cube numbers. So if you're struggling with that, all you have to do is get your calculator and type in 256 divided by maybe 64, and you'll see that it doesn't work. So maybe you do 256 divided by 27. Actually, 64 does work, sorry. So I did this on the calculator. I just took my number, 256 divided by 64, because I know that 64 is a perfect cube number, and I got 4. This means, on the calculator, this means that 256 could be rewritten as 64 times 4. So let me rewrite what I have so far. That negative 2 out in the front is going to still be there. And then I'll have the cube root of, I'm going to rewrite 256 as 64 times 4. And let me keep everything inside the root, the x and the y to the 6th. Okay, so now I need to determine, let me get this calculator out of the way. I need to determine what I could actually do the cube root of. So could I do the cube root of 64? Absolutely. So let me do the cube root of 64. But before I do that, let me bring down that negative 2 times. And what is the cube root of 64?
Cube root is 4?
Yeah, 4. So let me show my work, actually. I was going to skip this step. Cube root of 64, that's going to be 4. And then I'm going to do the cube root of something else that's nice in here. What's the next one? Y to the 6th. The cube root of y to the 6th, that's a nice one. And the other two, I can't do the cube root of 4, and I can't do the cube root of x. So that's going to still be in the cube root. Make sure you put that 3. Sorry about that. So the 4 and the x is still going to be in there. So do you see how I split up the roots? And now I could actually do the cube root of 64, that is 4. And I could actually do the cube root of y to the 6th. What is the cube root of y to the 6th?
Y to the 2nd?
Y to the 2nd, exactly. Now, if you're still struggling with that, remember the cube root is really the power of 1/3. So if you wanted to, on the side, you could do this. Y to the 6th to the power of 1/3. Now, when you have a power to a power, you multiply. 6 times 1/3, that's like saying 6 divided by 3. 6 divided by 3 is 2. So we end up with y to the 2nd, y squared. No more radical. Are you guys with me? And then, of course, this last one, it just comes down, the third root of 4x. Can't do anything with that. And let's not forget about the negative 2 that was out here in the front. So I need to multiply negative 2 times the number 4 and then write it in front of my answer. That's going to be a negative 8 y squared cube root of 4x. That is my answer. And right there, I was using perfect cube numbers. I rewrote to get perfect cube numbers. So that is using perfect cube numbers. If I had a square root, I would have used perfect square numbers. Now let's compare it with the factor tree over here. So the negative 2, I'm just going to leave it there. I know I'm going to have to multiply after I factor. And I'm going to go with 256. 256, I need to break it down with multiplication. And I want to go with the easiest thing in my mind, which would be dividing by 2. So 256 is really 2 times 128. You guys agree with that? Let me write that bigger. 128. You guys agree with that? 2 times 128 is 256?
Yeah.
Okay. Now, 128 could be broken down further. 128 could be broken down to 2 times 64. That's 128, right? And then 64 could be broken down further to 2 times 32, right? And then 32 could be broken down further to 2 times 16. And then 16 could be broken down to 2 times 8. And then 8 could be broken down to 2 times 4. And then 4 could be broken down to 2 times 2. Dang. But we did break it down. Now, on square roots, we wanted values that were squared. On cube roots, you want values that are cubed. Now, what does that mean? On cube roots, you want 3 of them at a time that you could pull out of the radical. Does that make sense? So if I were to take out these groups of 3, I will have 1, 2 on the outside. If I were to take out another 3 2s, then I'll have another 2 on the outside. Now notice that this 2 on this 2, I don't have a group of 3. So the 2 times 2, this guy right here, 2 times 2 is going to stay inside the third root as 2 times 2, which is 4. You guys follow me so far? Yeah. Now let's not forget that up here we had this -2, so I need to put that down there and multiply it by -2 at the end of it all. So far it's starting to look like our answer. So far when I do multiply -2 times 2, that's -4 times 2, that is -8. And we also have the third root of 4, but we have more stuff inside the radical. So we need to deal with this over here. So I'm gonna take, could I do the cube root of x? Could I do the cube root of x? Remember, cube root is the power of 1/3. Yeah. That's like dividing by 3. So that's just, cube root of x, you can't do it. Yeah. So we're just gonna leave it, right? So that x that's up there, I'm just gonna keep it inside the root. However, could I do the cube root of y to the 6th? Yeah, what is the answer to that? The cube root of y to the 6th. Y to the 2nd. Okay, let me write this on the side right here. The cube root of y to the 6th. Remember, the cube root is really the power of 1/3. So you have y to the 6th to the 1/3. That's 6 times 1/3. That's like saying 6 divided by 3. On cube roots, you want an exponent that's divisible by 3. On square roots, you want an exponent that's divisible by 2. On third roots, you want an exponent that's divisible by 3. So 6 divided by 3 is 2. So you will get a y squared, no more radical. So that becomes y squared, no more radical. So where are we going to put that y squared? Right after the 8. So we're going to put it in right here, y squared. So my final answer, as you could see, is the same thing as the other one. You just have to determine which one's better for you. Okay?